Hey cosmic explorers, welcome back to the channel. Today, we're diving headfirst into two of the most mind-bending concepts in the universe: black holes and the ultimate dream, time travel. So what exactly is a black hole? Well, imagine a star way bigger than our sun, running out of fuel. Instead of just fizzling out, it collapses under its own immense gravity, squeezing all its mass into an incredibly tiny space. The result? A region of space-time where gravity is so strong, nothing and not even light can escape. That point of no return is called the event horizon. We primarily talk about a few types: stellar mass black holes, which are typically 3 to 20 times the mass of our sun, are born from the collapse of massive stars. Then, there are supermassive black holes, millions or even billions of times the sun's mass, found at the centers of almost all galaxies, including our own Milky Way. How they form is still an active area of research, especially for the supermassive ones, but the common thread is extreme gravitational collapse. To understand black holes and their connection to time, we need to talk about gravity not just as a force, but as a curvature of space-time. Albert Einstein's theory of general relativity tells us that massive objects warp the fabric of space-time around them, much like a heavy bowling ball on a trampoline. The more massive the object, the greater the warp. And black holes are the ultimate warpers. Now, here's where it gets wild. Because black holes warp space-time so intensely, they also warp time itself. This phenomenon is called gravitational time dilation. Imagine two identical clocks. One is far away from a black hole, ticking merrily along. The other is plummeting towards a black hole. To an outside observer, the clock near the black hole would appear to tick slower and slower, eventually appearing to freeze at the event horizon. For someone falling into the black hole, their time would seem normal to them, but the universe outside would fast forward from their perspective. So, what if you actually fell into a black hole? Well, first, you'd experience something charmingly called spaghettification. The immense difference in gravitational pull between your feet and your head would literally stretch you into a long, thin strand, like spaghetti. Past the event horizon, current physics tells us you'd be crushed into the singularity, the infinitely dense point at the center. What lies beyond that singularity? That's still a huge mystery. Okay, so we've established that black holes play with time, but can they actually facilitate time travel? This is where we step from the observed into the theoretical and the truly speculative. Traveling to the future is actually something we know is possible, thanks to Einstein's special relativity. It's called time dilation, but this time, it's about speed, not gravity. The faster you move through space, the slower you move through time, relative to a stationary observer. If you were to travel near the speed of light for a prolonged period, when you return to Earth, you would have aged less than everyone else. You would literally have traveled into their future. Astronauts on the International Space Station experience this, albeit by a minuscule amount. They age slightly slower than us on Earth. But what about going to the past? This is where the concept of wormholes comes in. A wormhole, theoretically, is a tunnel through space-time, a shortcut that could connect two very distant points, or even two different points in time. Imagine folding a piece of paper and poking a hole through it with a pencil. That's conceptually how a wormhole works, bridging vast distances, or even temporal gaps, without traversing the space in between. The problem? To keep a wormhole open and stable, you'd need exotic matter with negative energy, something we've never observed and don't know how to create. So, for now, wormholes remain firmly in the realm of science fiction. Even if we could build a wormhole, traveling to the past brings up a massive issue: paradoxes. The most famous is the grandfather paradox. If you traveled back in time and prevented your grandfather from meeting your grandmother, you would never be born. But if you were never born, you couldn't travel back in time to prevent it. It's a logical nightmare. The laws of physics, as we understand them, generally try to prevent such paradoxes, suggesting that past time travel might be fundamentally impossible, or at least highly constrained. Black holes continue to be laboratories of extreme physics, pushing the boundaries of our understanding of gravity, space-time, and even the universe's origins. And time travel, while largely theoretical, forces us to deeply consider the nature of reality itself. Will we ever unlock the secrets of black holes to truly manipulate time? Only time will tell. But one thing's for sure, the universe is a place of endless wonders and unanswered questions, urging us to keep exploring, keep learning, and keep dreaming. What do you think? Are black holes the key to time travel? Let me know in the comments below. If you enjoyed this cosmic journey, please hit that like button, subscribe for more Astro Explorers, and ring that notification bell so you don't miss our next adventure. Until next time, keep looking up.